It took just 2 seconds to return a LLM response from a RAG application. This is absolutely crazy and it's mind-blowing. And in order to understand how to implement this, watch this video till the end and let's implement Langchain Streaming with Groq, a super fast LLM inferencing for RAG application. Welcome back. I've been sharing a lot of videos related to LangChain and open source LLM RAG. This is probably the 8th video in the playlist series, and it is quite exciting one because this is super fast. And jokes apart, in this video, we will implement chat with multiple websites using LangChain streaming and Groq to make our inferencing super speed. And trust me, this is really amazing. And obviously it requires an API key. And let's quickly get our API key so that we can start with the code implementation. In order to get your API key, you need to enter console.groq.com. I will attach the link in the description. So what you need to do is you need to create your account and you need to create the API key by clicking on this API key. So once you have done this, let's set up our API keys. And in order to install, there are 3 libraries that you need to install. One is Langchain Groq in order to use the LLM. Then we have Langchain Community, and then we have ChromaDB for storing our vector embeddings in the vector database. So let's set up our API key from getPass, import getPass. And there are 2 API keys that we need to use. One is the HF token because we need embedding in our RAG pipeline. I'll use Hugging Face inference embedding so that I don't have to load the model. I'll directly fetch it from the inference client. That's where I need Hugging Face token. So this will be my first token, and second is Groq API. So I'll just write getPass, enter your Hugging Face access token, and then enter your Groq API key. So let me run this. In order to proceed, we need to paste both our access token and as well as Groq API key. So I have stored it somewhere. Let me copy that and come back to you very soon. All right, so as you can see, I've already copied both my Hugging Face access token and Groq API key in this particular cell, and it is ran successfully. Let's proceed. And since I told you that I'll be working on chat with multiple websites, and these few articles on Medium are related to my GSOC timeline. And in order to you to get started with Google Summer of Code, if you are interested in open source and contributing to open source repository, you can probably check out my video in the description on how you can crack Google Summer of Code by making a nice proposal. So let's proceed. So these are my few articles from the GSOC time. And let's quickly import few statements from Langchain community dot document. It should be document loaders, import web base loader. And then we need to do splitting. For that, I'll use Langchain dot text splitter. I will import recursive character. I'll just wait for auto completion, and there it is, recursive character text splitter. Then I need from Langchain dot community dot text embeddings. So it should be embeddings. Import Hugging Face. I'll again wait for auto completion, and I need Hugging Face inference API embedding so that I can use my HF token and load the embedding model without even downloading it. Then from Langchain community, I need a vector store, vector stores, import chroma. So these are the 4 steps that I need to use. One is get your data, proceed with the chunking, store that in a vector database using your embedding model. So let's write the individual code for it. I'll initialize my web-based loader, and I will pass all the URLs inside it. And once you pass your data inside web-based loader, you need to load the content. And in order to load the content, you just simply have to use loader.load. And what this particular step will do is it will extract the entire content from your all the URLs. So you can verify it by running data. And if you can see whatever articles that I wrote, I'm able to see the content out of all the 3 articles. So we are able to successfully fetch the data. And the next step is we need to do the chunking. And before we can proceed with chunking, we need to initialize it. What do we need to initialize? We need to initialize recursive character text splitter by adding a chunk size. So chunk size, ideally I use 1000. So I'll go with 1024, and chunk overlap, I'll keep it to be 150. And now you need to create a smaller chunk of your document. So you need to use text splitter dot split documents. So I'll just wait for split documents, and you just have to pass your chunks. Sorry, it's actually data. All right, so we have done with 2 steps. We get the data, we load it, and then we chunk it using recursive character text splitter. This is where we need to assign chunk size and chunk overlap. Let's proceed with embeddings. Embeddings equals to, I'll be using Hugging Face Inference API embeddings. Here, you need to pass your API key. Your API key is nothing but your HF token, which is already defined using getPass. And then you also need to add your model name. There are various open source embedding models that you can pick, but which one is better? So this is the leaderboard for massive text embedding benchmark. And if you can see, there are tons of open source embedding model which have been evaluated on different benchmarking, that is model size, memory usage, embedding dimension, maximum token, average, clustering average, and so on. And in order to pick the best one, we need to look into the memory usage. Because we are using embedding on Inference API, it is better to pick an embedding model which is very close to 1 or 2. This is where I'll pick this UAE large V1. So this is the model that we will be using. So let's copy the model name and paste it over here. So model name equals to where is AI UAE large V1. So this is the embedding model that we will pick. And as you can see, it is running successfully. Now let's define our vector store. To define our vector store, we need to define chroma from documents, because LangChain, eventually when you load the data, it is in form of document with the page content. So you need to pass your chunks along with the embeddings. And there is one more parameter called persist directory. Persist directory is nothing but whenever you upload a new document, in order to avoid re-indexing that particular document, you can use persist directory and save the index in a variable called db. This can be anything. You can name it as vector db, vector store, db, index 1, index 2, so on. It can be anything of your choice. I'll just pick it to be db, and it's going to take a few seconds until this run. And once you run and store your vector embeddings, you will be able to see a directory called db in your folder directory. And once you have done this, let's get started with RAG. And in RAG, there are 3 steps that we need to do. The first step is retrieval. The second step is augmentation, where you need to augment your prompt. And third step is you need to initialize your LLM, which is the generation model. Retrieval, augmented, generation. This is the 3-step process. And for generation, we'll be using Groq. And once you have defined your LLM, you need to create a chain. You need to create a chain using Langchain Streaming. So this is what we're supposed to do now. And the first step is very simple. Once your vector store is done, you need to create a retriever equals to vector store dot as retriever. So this is how you initialize your retriever. And you can also change the search type. And in our case, I'll usually use search type to be MMR, which is a maximum marginal relevancy algorithm. And once you have defined it, you just have to run your retriever. Cool, that's it. That's how you define your retriever. Now what we need to do is we need to augment our prompt and initialize our LLM. That's where there are few more import statements that we are supposed to use. One is from Langchain Groq. I will import chat Groq, and from Langchain dot core prompts, it should be from Langchain dot from Langchain core dot prompts. I need to import chat prompt template. And since you're using Langchain streaming, we are supposed to use Langchain expression language. If you are very new to this term, you can probably check out the third video where we have explained in detail how you can use Langchain expression language and what are the benefits of it. And in order to use streaming, we have to use Langchain expression language. And in order to use that, we again have to use Langchain core dot runnables import runnable pass through. From Langchain dot schema, you need to import whatever structured response you need. In our case, whatever question you ask, you need to get the response in string. That's where I'll be using str output parser. So these are the 4 steps that I need to initialize. And now let's get to the prompt template where you need to augment your prompt. And let me quickly copy paste the prompt from my previous tutorial videos and get back to you soon. All right, so this is my template. I have just defined user. You are an AI assistant that follows instructions extremely well. Please be truthful and give direct answers. Please tell I don't know if user query is not in context. Keep in mind, you will lose the job if you answer out of context question and you just pass the context. Context is nothing but whatever document you're retrieving and query where you are asking your question. And then you just have to return the LLM response. So this is the template that I'll be using. And now you need to create a template of it using chat from template from template. Here you need to pass this variable. And in LangChain, your context and question are nothing but your input variables. And wherever you add your input variables, when you define your template, you need to format it. This is where when you create LangChain expression language, you can override it using runnable pass-through. This is where LangChain expression language, in short, LCEL, is very powerful. And now we will define our large language model. So let me delete this cell and create a new cell. Chat model, I'll define chat Groq. And in order to define chat Groq, there are a few parameters that we need to define. For example, temperature equals to 0.1. And then you also need to add your API key, which is Groq API key. And you need to define the API key, which we have already defined using getPass. Copy this. And then you need to define the model name, which is Mixtral, which is a very powerful open source LLM, 8x7b. And then you need to pass the context window size, which is 32,768. So this is the model name, and you just have to run it. All right. So we have almost completed the entire step. Let me quickly regroup to you all the things. First thing is we get the data, split into chunk, create embeddings, store that in a vector database. Once you do all this process, you need to create a retriever from your vector store where you need to define the search type. You can leave it default as well. And then you need to define the template. In template, you need to define the prompt. In prompt, there are 2 input variables. One is context and one more is question. We will override this using Langchain expression language by adding both prompt, chat, and a output parser. So output parser is nothing but our str output. Let me copy this. str output parser. This is a function and let's call it. And once you have defined this, we now need to define the chain. So in order to define the chain, you need to open the curly brackets. So let's define chain. Chain equals to, open your brackets, and you need to override your two input variables. Those two input variables are context and the another one is question. So context is nothing but whenever a user asks a query, you need to return the relevant documents. So in order to do that, we need to use retriever with config, and here you need to pass run name, and run name by default is docs. And for question, since there is no user query as of now, you can directly use runnable pass through. So what runnable pass through will do is it will just pass, that's it. And once you have defined your input variables, you need to define your prompt, you need to define your large language model, and whatever your output response is, which is output parser. So this forms the chain. And once you define the chain, the final step is to perform Langchain streaming. It is just 2 lines of code. So let's write the query. My article was related to CA Microscope, the organization which I was working at Google Summer of Code. In order to get started with CA Microscope, we were supposed to do multiple cloning of GitHub repository, then using Docker image. So let's use a LLM to see how we can get started with CA Microscope using Docker. How do I install CA Microscope using Docker? So this is my query. And in order to use Langchain streaming, we just have to pass a loop using chain.stream and pass your query. So that's it. And print each chunk in a single line using end and flush to be true. So let's see how quick the response is. I'll run this cell and probably it should take less than 5 to 10 seconds and it is very fast. So let's see what the response is. Hopefully it should run quickly. So as you can see, we got the response in 9 seconds. That is quite good. Sure, here are the steps to install CA Microscope using Docker. This is quite big response and it usually takes time to generate the entire response, but it just took 9 seconds and you can see the length of the response. And this is it. This is it with this response time. So as you can see, it's just 9 seconds and the installation is accurate. We had to use different repository to clone CA Microscope, Caracal, distro, and other thing. I can verify it using my article where I've attached all the URLs. And you can also check this Colab notebook in the awesome RAG repository that I've created. So this is it from the video. And this is really amazing on how the advancement is going on. Groq has really made a terrific impact when it comes to super inferencing of an LLM. So I hope you followed this video and you were able to understand. Like this video and subscribe to the channel for more videos on RAG, LLM, generative AI, and everything around it. Thank you so much for staying till the end. Let's see you in the next video.